Hey everybody, this is the SIG Usability meeting on Tuesday, August 2nd. And I am filling in for Tasha today. She said that she had a meeting that she unfortunately could not move, but still wanted to give Brian a chance to do a demo of the KPT project. So that is the first topic on the agenda today. So Brian, if you want to take it away with your topic.
Okay, let me see if I can share my screen. Just a minute. All right. Okay, I think you should be able to see that now. So in terms of a little bit of background, this is an approach that I've been calling configuration as data, and what the UI can do with the help of our backend, which we call the package orchestrator, is it can actually modify, configure, read and write the in storage. So instead of like the Kubernetes dashboard, which interacts directly with the live cluster states, this UI can interact with the configuration in Git, and then a GitOps tool can apply that state automatically to the cluster. So the idea is to enable capabilities that today kind of bring together the capabilities of GitOps style tools or infrastructure as code style tools and traditional tools where we can apply, traditional UX techniques to mitigate domain complexity, to provide step-by-step guidance and things like that. So we started with the simplest possible Kubernetes scenario, which is configuring namespaces or provisioning namespaces. But what we're looking at now is how to apply this to the thing that most Kubernetes use about, which is but kind of something that's happened in the Kubernetes ecosystem is that most there's a kind of an assumption that most people are deploying their applications with a configuration tool like Helm or Customize or something like that. So the user experience developed in most Kubernetes dashboards, portals, consoles, UIs, etc., are somewhat incomplete. So, for example, I can show the Kubernetes dashboard. Let me see if I can refresh my credentials here. So if I go to the deployments, default namespace, all namespaces. Okay, if I look at deployments and I want to deploy something, create a new resource in the Kubernetes dashboard, for example, the form view is somewhat incomplete. So I can actually, do kind of a standard Nginx example. And show advanced options, but advanced options is actually still a tiny subset of the options that are actually in the pod spec. It's a somewhat incomplete experience. This KDS YAML tool actually has a somewhat more complete experience, but it's kind of flat. It just presents sort of all the options together. So I think, an interesting question is what kind of step-by-step guidance would be more helpful in constructing the Kubernetes resource description for real-world use cases. And I think we're just starting down that path, but just to show the namespace example. So in this example, there namespaces and the associated policy resources like resource or RBAC role binding, for example, have a lot fewer options. So first present a flat form, but you could imagine if there are more options, you would need to structure it more with progressive disclosure and step-by-step guidance and smart defaults and things like that. But what we can do here is actually create a blueprint. I'll just call this a base namespace blueprint. And the blueprint you can think of as kind of like a template, except there's no actual templating in it. It's more of an archetype or an example of the set of resources and a set of instructions for how to create variants of that when you're actually utilizing the blueprint to create specific deployments from it. So you can think of that as like a macro in some sense. But if I say, okay, create, what this is using under the hood is a project called kept, which is a simple packaging tool that supports Git, and we're working on container image or OCI support for storing the configuration as well. And it will execute a set of functions to transform the configuration. So instead of intermingling template syntax or some configuration language like JSONit or QLang or Starlark or DAL or something, or a general purpose language like TypeScript or whatnot, actually in the configuration is just represented as data as Kubernetes YAML. And then the code, the functions manipulate the data. So much more like a traditional UI tool or CLI tool or automation tool that interacts directly with the live state and modifies, and writes. We manage configuration in a similar way. So what we can do is we can say, edit the blueprint. Since we want to create a namespace blueprint, we can add a namespace resource to the blueprint, and say we want to use Istio, so we'll enable Istio injection. And we could provide, if that's a common thing people do, we could provide a first class feature for that. But then we can save that. And that's, namespaces don't have a lot of attributes, so that's pretty easy. So we will just leave it at that. And then, we need to add a role binding to the namespaces, and we will assume that there's a cluster role called app admin. So we will add a reference to the cluster role app admin, and we will bind that to a group and say that that group has a form decided by the platform team. We could also bind it to a service account and add a service account. But we'll just say it's example.admin at whatever our company is what the platform team is to say. So then, so that's kind of the simplest possible blueprint. Like I said, you can think of it as a template or a prototype, but it's just an example. So then, we need to provide the recipe for variants for that when they're provisioned. So that's done with functions. So one function we need is to set the namespace name to some unique value when we create namespaces from this blueprint. We also need to change the group in that role binding. So we'll actually use a transformation that we repackaged from Customize to to modify the role binding. That's the trickiest bit. That's a common transformation. We could actually write a dedicated function for that. But apply replacements, you can think of it as a fancy kind of patch. But my general observation from looking at a lot of Kubernetes configuration packages is that the same kinds of patterns are templatized in all the packages or Helm charts, whatever, that contain the same resource types. So what we're doing here is taking that logic out of the packages and out of the templates and putting in functions that we can reuse across arbitrary packages that contain those resource types. So in this case, we are going to use the name of the package, which we put into this config map here automatically for now. We're going to use the name of the package to set the name of the namespace, which is kind of a nice, simple convention that creates a unique identity for every deployable instance. And we want to modify the role binding. And we want to change that group string. And we only need to change that first part of the group string. So this provides value so we can see what we're actually changing. Yeah, we want to replace this examining. And then we can go to the kept file and add our functions. So we need a function to set the name of the namespace. So we have a function, set namespace function for that. And we're using the name of the package. And then we need to add a function for that apply replacements configuration that we specified. We're planning to create a way to do this automatically, to automatically map these input types to functions so people don't need to manually add the functions. But for now, I can just do that and use autocomplete effectively to identify that. So that's basically it. We need a way to be able to test this to make sure it does what we expect. But right now, we'll go ahead and save this and hope that it works. And what we've done is we've created this prototype, as it were, for maybe my credentials expired. Nope, it's just a little bit slow for some reason. So once we have done the edits that we think we need, we can propose a change, and then someone else on the team could review and approve the change. And what we've done here is create an experience where it can be reviewed directly in the UI. Now here we're starting from scratch, so there's nothing really to compare with. They can just take a look, and you can make that view as nice or as structured as you want. Like I said, these resources are pretty simple, so we just kept it simple. Go ahead and approve that. And then this blueprint becomes available for deployment. So we can deploy right from here, or we have the model we're using is we're fully rendering all of the configuration to deploy in advance. So instead of having a template that renders and doesn't apply on the fly, we're doing it in advance so you can completely see what you're deploying. You can present it in a structured way. You can validate it however you like, and do automated checks, review and approval, whatever you want. Here, we just use the same workflow for simplicity because this is kind of a proof of concept. But we deploy these things into this other repository we call namespace instances. Now, these things actually are repos in GitHub. So what I just did is I created this, the base namespace blueprint, which now here is in my repo. And I never really had to look at YAML. I never really had to do all those git commands. And we can see, the content that I put in there is in there. So we're going to do a similar thing with the actual namespaces that I want to create. So now that I created that blueprint, it's in the list of available blueprints because we have that repository specified as the repository to go look for blueprints. And I can just create a backend, say, for this and say, yeah, go ahead and create the deployment. Now, in this case, all of the changes, all the edits are completely automated. So here we see that the namespace is changed to the name of the package, backend one. The namespace value in the role binding was also changed to backend one, and that group was replaced with backend one as we expected. So that's actually all the changes we expect. If we wanted to do further customizations to this, we could edit just as if the blueprint, and you can think of that as adding patches on top of the base blueprints, except that you don't have to construct a patch manually. It automatically diffs with the blueprint when you do an update. So instead of always patching the base as we would do in customize, the diff is computed when we do an update from the upstream. So like I said, it's the same workflow. So we could propose this change. I can show the diff from the upstream, I think, or maybe not. That doesn't seem to be working. Yeah, that doesn't seem to be working for some reason, but we could show the diff from upstream. The diff is not super interesting because these are the changes that we expected it to make. But once we go ahead and approve this will get merged into that other repository, and we should see that here. Here's backend one. So yeah, that's stored. And now, like I said, the GitOps process in the background can actually sync those resources to the cluster. So I can show that. And here's the backend one resource namespace already in the cluster. So by making these changes in Git, we're effectively directly changing the state in the cluster. And this linkage between the two, we're using config sync in this case because I'm most familiar with that. But you could easily use Flux or Argo CD to do the same thing. I have annotations here that actually map this resource back to the source of truth. So this says it came from backend one namespace.yaml. So if we had integration with the configuration UI, we'd actually put a link there and go back and forth between the two. So if we could make it so that someone couldn't make the mistake of just doing edit directly through the live state and would be redirected back to the configuration UI to make a change, but making a change should be just as easy to make it through the configuration as it would be to make that change through live state. So I think this is an interesting model, like I said, because we can apply all the UX techniques that we would apply to a live state UI or to a Git provider's UI. We could apply to using mechanism. So that enables things that people think don't use a UI to manage a production environment or not today. This actually enables that equation, and it actually would enable people to make changes through UI and still have repeatability. I can go create as many namespaces as I want from the same blueprint, and you get pre-deployment validation and change control review and approval. Also versioning and undo. So I've only created one version, but we have a list of revisions here. And, kind of like in Google Docs, you can just select a previous revision and say, revert to this previous revision, right? So undo for Kubernetes generally, effectively. So yeah, I was interested to see what people think about the approach and, whether there's interest in trying to apply, standard sort of UX strategies to the blueprint creation process effectively, right? So today, if you want to create a Helm chart, for example, you basically have to start from scratch, author the resources, and then add template every attribute is a typical thing that people do, like every possible conceivable attribute that someone would want to change. And there's not really much help for that authoring experience. Actually, especially for this case, because Helm create creates a minimal blueprints and service and maybe ingress, I don't remember, but it doesn't do that namespaces. Here we can actually provide a base blueprint and then create blueprints from other blueprints, just like I created these deployments from. So you could potentially create classes of blueprints for different scenarios, for namespaces, for applications, for other things you needed to do in Kubernetes. But even for creating those base blueprints, some of the resources, like anything with a pod spec, for example, is pretty complex. So being able to provide more guidance and more structure around that, I think, is an interesting prospect that hasn't really been much explored. I've looked at a bunch of dashboards. I've looked at, this is the Kubernetes dashboard. Also, I looked at Lens and Octant and, this k8syaml.com from Octopus. This is probably the most complete example I've seen for generating configuration. But here, there's no way to deploy. It's just like I have to copy paste the YAML. Whereas we could similarly in the backstage, and you could deploy there. So that's about all I wanted to show for the demo, because mostly I wanted to get people's impressions and see what people how people felt about the approach, whether it's useful, not. Any thoughts?
I think it's interesting.
Silence.
So I watched your similar demo, I think from a couple of months ago when I was preparing for this meeting, and one of the things that struck me is like you could have the ability to do like I know when I used to work on a platform team, and one of the challenges that we had was when we tasked our app engineers with defining their own services and then deploying them onto the clusters that we managed. I called it the Control-C, Control-V problem. So we managed it all through Git, right? But they would just go take somebody else's service, wholesale copy it, paste it, change the two things that they needed, and then commit it, and then never look at it again. So from that perspective, like the blueprint idea, I think would be very helpful, right? Because you could enable platform teams to say like, no, just like don't copy and paste, just use the blueprint. So a couple of the other thoughts that I had with regards to like usability is like, I'm thinking of another piece of software that I use for like 3D printing, right, and plating, and it's got like an easy, a medium, and like an expert mode, and it seems like this could really lend itself to that. I noticed as you were doing the demo, like there were some deep internals that could show up as part of like a blueprint that maybe a novice user wouldn't really know or care about, or could easily blow their foot off, but you could abstract that away through the UI, and really, make it easier for newer users to be able to use the thing, and then make it easy for experts to also be able to go and like dial each knob that you would want to expose, like you said, through like a Helm chart or something.
Right. Yeah, I think what I've seen as a common pattern for teams with the scenario you mentioned is that they create kind of a universal Helm chart that parameterizes any attribute that anybody wants to use. And then the values.yaml ends up being about as large as the entire template. So people are not copy pasting the whole chart, but they're copy pasting the values.yaml and doing the same thing. So, structurally, it's a little bit simpler to merge in an automated fashion, but otherwise, is pretty much as complex if all the default values are in there and whatnot. And to some degree, that's what they're giving up when they do that is it's no longer an API. So none of the standard tools work with it. There's no standard documentation that goes along with it about what the values mean. There's no standard UI for presenting those values. Other than as just a kind of a generic form, or even as just the YAML itself. So understanding what values are available and what changing those values does almost always requires looking at the chart, or asking someone who's familiar with the chart. So I think my general sense is that we can have a lot more leverage if we build on the standard types, and both for Kubernetes and the extensions around Kubernetes, like Istio and Knative and Argo CD and whatever. Then somebody can write that logic one time, whether it's in a function or in a UI, and everybody else can leverage that and can reuse it. So we're still in the early stages, but yeah, the thing we're looking at next is Kubernetes applications, so deployments and services and ingress and stateful sets and whatnot. And that's where we'll have to evaluate how important each set of knobs is for the typical user in order to figure out how to structure the UI in a way that's less overwhelming.
Yeah, I think, and this is, I guess, coming as a question from like a novice, this idea of like optimizing usability, but for building the blueprint itself, it would be interesting to get like y'all's thoughts about how you balance like suggestions on how to like manage this like config workflow and maybe like breaking down these like steps granularly against just this idea of like having to click a lot of buttons and like not being able to see everything at once, or like what's the trade-off there and how do y'all manage that? I guess when building a UI like this.
I mean, in terms of seeing everything all at once, are you thinking about just seeing all the resources all at the same time, or?
Yeah, exactly. Or like, this workflow, like it was like a lot of, okay, I did this part, like let's move on to the next part. I did this part in terms of, yeah, managing that type of like process.
Yeah, I mean, I liked Elliot's idea of having different modes for people with different levels of familiarity. People who need more step-by-step guidance may follow the step. People who are more familiar may skip around more. The analogy I like to use is TurboTax, which the taxes are super complicated. It has a sort of a wizard that walks you through it, but it's not an abstraction in the sense that it's not preventing you from changing any particular field of any particular form. You can actually go through the step-by-step where it asks you a bunch of questions and populates information, or you can choose, I'll choose what I want to actually go fill out, and you can just hop around and select, flip between deductions and income if you want, and things like that. And then there's the form view, which is really the raw view. And if you change a value in the form view, it does not get overridden by the wizard. At least I've never had it happen to me. So, it's providing, it's using standard UX approaches to mitigate the domain complexity, and that's even more complex than Kubernetes for sure. But letting you choose the sort of the level of simplification that is appropriate for you, right? So like the first time I used TurboTax, I went through the step-by-step guidance, and then after that, I was familiar with how it was laid out, I hopped around, said, I know these parts are not relevant to me. I'll just skip those. So that's sort of the mental model for how I'm imagining it. And another example of that I've seen that is done well is my ASUS Wi-Fi router had a mode like that where, there's a simple mode where, almost everything is automatic, and I just have to enter minimal information like what, actually even, generating passwords and stuff can be automatic, and I just have to know what it is. But, there's also an advanced mode where I can go and change lots of networking knobs that only a networking expert would know. And if I change those, they don't get stomped by the device. So that's only two modes, auto, everything, and advanced. But I think shows the concept, in a different domain can also work, where it's not abstracting the underlying details, it is simplifying how to manage those underlying details. And something I've seen since the beginning of Kubernetes is that abstraction is hard. Like people from the beginning, even when Kubernetes had vastly fewer knobs and vastly fewer resource types, people tried to abstract the resources with, JSON or some other configuration tool, and is very difficult. Like I'm not aware of a lot of successes there for people trying to do something that's very general purpose, like an off-the-shelf application or a blueprint that works for all the applications in an organization or something like that. It can be very, very challenging. Also, I think a lot of times people get caught up on reducing boilerplate or, applying minor simplifications, and that ends up not having a lot of value. It just gets in the way more than anything else. There is something to be said for not needing to know exactly how the Kubernetes YAML is formatted and things like that. But we should have tools that can help with that. Like IDEs can help with that. For example, a UI could help with that, or CLI. So kubectl has, if you know the right combination of flags, you can use kubectl create to create the YAML for you. Kubectl creates, -- client equals dry run or whatever it is now, -o YAML, and it will spit out the YAML for you. So I actually have been using that, and it's not bad. If we made that more obvious, or a first class, new command like kubectl generate or something like that, I think that could be a pretty nice experience. But this general idea that I'm going to generate and transform the configuration with the assistance of tools, and then apply it to the cluster as a distinct step, I think would be a good model to adopt. I mean, Kubernetes users, for the most part, have adopted that model already, whether they're using GitOps tools or, they're doing kubectl apply or they're using Helm on the command line or whatnot. But so just getting into that mindset that, the Kubernetes API is natively declarative. So if we have a declarative representation of that serialized and stored, then we can get, pretty much all the benefits that people want from GitOps style workflows. There are a few tricky bits. So, one thing I didn't show is upgrade. So upgrade, if not for upgrade, everything I showed you could basically just do with macros, right? Like you could take a blueprint, run a macro, spit out a variant, and that's nothing new really. The tricky bit is actually, okay, if someone changes the blueprint, how do you update all the deployments that were generated from that blueprint? So that's where this, diffing and patching mechanism is actually needed. And we're still working on, exactly the right semantics, but my mental model is kind of similar to a customized base where the blueprint is providing defaults. And if the consumer hasn't overridden those defaults and those, new defaults get Arguably, you shouldn't change defaults in the blueprint because changing defaults is sort of a breaking behavior. But just as an example, if you make a mistake in a blueprint and then some deployments get created from it, and you want to fix all of those, you want to put the fix in the blueprint and then roll out that fix in all the direct instances, right? So just as the example I showed was pretty simple, but even then, I run this demo lots of times, and half the time I forget to do something, right? Like I forget to add the apply replacements function, which should be automated, but still, if I forget to add the istio injection label to the namespace, for example, I would want to add that to the blueprint and then go update all the deployments to get that change, right? So I think that is the sort of the interesting bit, or one of the interesting bits. There are some other challenging things we're working on. Application configuration is one that we're looking at right now. Application configuration is in a wide range of different formats. So we've been looking at a number of off-the-shelf Helm charts, and the app config is in formats like INI and TOML and XML, and some are in JSON and YAML. Application properties is another one for Java applications, properties files. So there's like on the order of half a dozen formats that are not Kubernetes resource formats. So, if someone changes an attribute, how do you do this diff and merge correctly? So that's, something we're working on right now as well.
Do you also have that same problem with versioning and upgrade of the mutators as well?
Yeah, so that's another thing we're thinking about. The platform team probably wants to manage the versions of those functions. Right now, the tags for we're using containerized functions, and the tags are in the kept file, and that probably is going to be, it's good for predictability, but it's probably going to be a maintenance issue. So one thing we're thinking about. So our backend has made all the configuration accessible through APIs, through Kubernetes APIs, actually using an aggregated API server. So that enables us to run all kinds of automation on the configuration content in storage. So in theory, we should be able to discover all the set of packages in a repository, check what function versions they're running, for example, change those and propose that change, and do whatever automated validation or testing we want to do, and then merge those changes in a progressive fashion. So that conceptually should all work. We need to actually go build a prototype of that and prove it out. We did build a prototype of bulk upgrades, so update a blueprint and then discover all the packages that were derived from that blueprint and propose upgrades to those. And that worked great. The workflow is a little bit tedious, so we probably would adjust the workflow so they can be bulk approved, bulk reviewed and approved. We can actually run automated checks already. So I showed mutator functions. We can also run validator functions. So we could run automated validation checks. You can think of them conceptually like GitHub statuses or things like that. Or admission control in Kubernetes. It's effectively admission control for Git. So we can prevent merging changes that fail the checks, or we could automatically merge things that pass the checks. But yeah, and the workflow can basically be whatever people want it to be. We have the base. After any mutation that's made, we run all the functions again, so they need to be idempotent. But that's the admission control aspect of it. That mechanism is pretty flexible. So, a lot of different workflows could be built onto the primitives that we built. But yeah, and definitely bulk upgrades of functions is something that we've already run into because we've iterated several times on the set namespace function, trying to figure out what behavior we want from it, because some packages deal with resources from multiple namespaces, for instance. So it's definitely clear that it's going to be something that platform teams need to do.
And I think the other thought, kind of riffing on the, making it easy for some and having more advanced for others, is possibly having better descriptions in terms of what the mutators do, such that it's more obvious to people, which mutator to pick, etc.
Yeah, absolutely. I'm also been thinking for the application use case, we will want the UI to understand certain mutators that we expect to be commonly used, much like Customize has some built-in transforms that are commonly used. So we have a kind of a general purpose discovery mechanism where we can register repo and discover what functions are in there, and then in theory we could attach metadata to those functions and filter them in various ways. So currently we have filtering based on whether a function is a mutator or a validator. So if you are adding a validator, it only shows you the validator functions in the repo. Definitely one thing I've noticed is where the input type is well structured, like in the apply replacements case, we could automatically know what functions get run in that case, and the user wouldn't have to deal with it. But also for the resources in the blueprint, like namespace, role binding, usually there are functions that apply to specific resource types, like set namespace, for example. And that applies to most resources because most resources are namespaced. But we have some specific functions that apply to specific resource types, so we can suggest functions based on what resource types are in the package, which is a more generalized version of invoking a specific function for a specific input. So we're looking at things like that. But yeah, in terms of modifying lots of the pod spec, we're trying to figure out the balance between supporting those edits directly in the UI and creating functions that can modify parts of the pod spec, because there are some of the attributes we want to be common across all the applications in an organization, for example. So for those, we would like to have a function that we can just say, make it so, like make sure none of the pods are privileged, or none of them auto mount the service accounts, things like that. So those things will probably, those best practices as platform teams develop them, they would probably want to create functions for those and then automatically apply those functions to all the packages. So we're also looking at attaching functions at the repo level. So again, with this admission control concept, so the platform teams can ensure that all of the deployments obey whatever specific rules they have with respect to security or networking or whatnot.
Cool. Well, thank you for running through that demo, Brian. I found it really interesting. I hadn't actually heard of the project until I saw your previous demo, so I was excited to get to hear you chat about it today.
Yeah, Kept has been around for a little while, but a lot of this functionality is new since May.
Yeah.
So like the UI plugin and the package orchestrator backend in particular. And we also just recently open sourced config sync as well. So now it's kind of a more comprehensive package for automating. I changed the tagline of the project to automate Kubernetes configuration editing, because I feel like that is really the unique aspect to what we're doing. Is in all the other 100 tools for managing Kubernetes, you have to write the configuration by hand. At the end of the day, you're in a text editor or an IDE, writing it by hand. And with this approach, ID is sort of the proof of concept, but I think as we get into security remediation and tools that try to instill best practices and things like that, there'll be more and more automation that we'll be able to apply to constructing the configuration. Machine learning is another thing we're looking at. Most people set this way. You should probably set it that way.
Code pilot for your manifest.
Yeah, exactly.
Cool. Does anybody else have any other questions about the demo or any other audibles they want to call for the topics? We have about 10 minutes left. Cool. Then, yeah.
I have a question, which is how much does SIG usability interact with the other SIGs like SIG UI and SIG CLI? Like CLI in particular, I think I haven't seen a lot of examples of UX really trying to inform how the CLI is designed. I mean, Kube control itself at this point is hard to change because it has so many users and so much documentation and things like that. But for things that are additive, and we could look at how to streamline the experience more for what people actually do. Anyway, just as one example, I don't know how active the dashboard effort is at this point in terms of making changes versus just keeping up with Kubernetes evolution, but could be interesting or useful.
Yeah, I don't have a good answer for that, but I feel like Tasha probably would be the person to know. So I can definitely ping her with a follow up for you on that.
Thanks.
Cool. Anything else before we wrap up today? Okay, awesome. Well, thanks everybody for coming out. Thanks again, Brian, for the demo. And y'all have a great rest of your week.